Very good morning, friends. Today, let us discuss with antidotes. What do you mean by antidotes? As the name indicates, anti. It is anti to poisons. Which antidotes are the agents which stops the effect of poisons? These are antidotes. Before that, what is poison? Poison is any substance when it is absorbed or introduced into the body intentionally or unintentionally, it causes death or at least an illness. The one compound which gives the anti effect of these poisons are antidotes. In other words, these are the agents which counters the action of poisons. These antidotes can be classified into three types. The first class of antidotes are physiological antidotes. Physiological antidotes produces the effect which is opposite to that of poison. A very classical example for this physiological antidotes is sodium nitrite in cyanide poisoning. Sodium nitrite is used as an antidote to cyanide poisoning. Cyanide, as we know, it's a very notorious chemical. The 2 to 4 mg of cyanide drug, that is in the form of potassium cyanide or sodium cyanide, is enough to see hell or heaven by a person. It's a very strong poison. And sodium nitrite can be used to counteract the poisoning effect of cyanide. Another class of antidotes are chemical antidotes. As the name indicates, they are the antidotes which acts by changing the chemical nature of the poison. Sodium thiosulfate is another drug which belongs to the class of chemical antidotes used in the cyanide poisoning. Other than these two, physiological and chemical, another class of antidotes are mechanical antidotes. As the name indicates, mechanically it prevents the absorption of poison. Activated charcoal is a classical example which belongs to the class of mechanical antidotes. Here, activated charcoal prevents the absorption of cyanide or any other poison, so that if it is not absorbed into the body, its effect is not seen or reduced. Let us look into this in detail about of these three classes of poisoning antidotes which belongs to the class of physiological, chemical and mechanical. Let us look into the first class, physiological antidotes. The sodium nitrate. Sodium nitrite is a chemical with a molecular formula NaNO2. sodium nitrite. NO2 is nitrite. Molecular weight of this sodium nitrite is found to be 69. This can be prepared by following this method. First, we carry out catalytic oxidation of ammonia. Ammonia is easily available in the market. I'll take ammonia and oxidize with oxygen by using an oxidizing agent like platinum. Platinum acts as a catalyst. In the presence of this platinum, ammonia reacts with oxygen when it is heated at 800 degrees centigrade. Very strong reaction conditions, and the ammonia gets oxidized to nitric oxide or nitrogen oxide with the liberation of water. 4 molecules of ammonia reacts with 5 molecules of oxygen in the presence of platinum as a catalyst to give rise to 4 molecules of nitric oxide and 6 molecules of water. The nitric oxide is NO, which is also called as nitrogen oxide or nitrogen monoxide. The nitric oxide which is formed is dissolved in sodium carbonate solution and which reacts in the presence of oxygen. It gives rise to sodium nitrite, that is NaNO2, with the liberation of 2 molecules of carbon dioxide. Summarizing, 2 molecules of sodium carbonate react with 4 molecules of nitric oxide in oxygen. It gives rise to 4 molecules of sodium nitrite with the liberation of 2 molecules of carbon dioxide. Here, nitric oxide, which is formed by oxidation of ammonia, reacts with the oxygen and it gets converted into nitrite ion. The nitrite ion, which is formed, reacts with sodium bicarbonate, NO2 minus, combines with Na to give rise to NaNO2. This is the industrial method of preparation of sodium nitrite. There is another method of preparation of sodium nitrite, that is catalytic reduction of sodium nitrate. NaNO2 is sodium nitrite. Sodium nitrate is NaNO3. If I reduce this by using a reducing agent, the reducing agent we use here is a mild reducing agent like calcium sulfite or lead powder. NO3 gets reduced to NO2. Reduction is removal of oxygen. As the oxygen is removed, it gives rise to NaNO2, that is sodium nitrite. This method of preparation is used as a laboratory method. Sodium nitrite is a granular or crystalline form of powder which is white in color and salty in taste. Sodium nitrite is easily soluble in water and sparingly soluble in alcohol. It is deliquescent. What it means? Deliquescent means it absorbs moisture and it converts into liquid. And sodium nitrite should be stored in well closed container. Otherwise, it reacts with the oxygen present in the atmosphere and gets oxidized to NaNO3, sodium nitrate. We have seen sodium nitrate, when it is reduced, it gives to sodium nitrite. Sodium nitrite reacts with the atmospheric oxygen and gets oxidized to sodium nitrate. That's why storage of sodium nitrite in well closed container away from oxygen is a requirement. Chemically, they can be used as a reducing agent. And when it is exposed to dilute H2SO4, it decomposes. These are the salient properties of sodium nitrite. Chemically, it is used as a reducing agent, and therapeutically, it is used as an antidote for cyanide poisoning. Sodium nitrite is given through intravenous route as a two-step treatment regimen. We first administer sodium nitrite intravenously, and this is immediately followed by administration of sodium thiosulfate. Sodium nitrite and sodium thiosulfate are used together for the treatment of cyanide poisoning. How this gives an antidote effect for cyanide poisoning? Let us discuss this. And it is found that the cyanide poisoning is counteracted by sodium nitrite by two mechanisms. The first mechanism involved is formation of methemoglobin. The hemoglobin present in the body of a living organism oxidizes to methemoglobin. Methemoglobin, in other words, is an oxidized form of hemoglobin. Sodium nitrite oxidizes the hemoglobin present in the body to methemoglobin. The sodium nitrite, which oxidizes the hemoglobin to methemoglobin, reacts with cyanide. The cyanide has high affinity to ferric ions present in the methemoglobin. In hemoglobin, iron is present in ferrous form. When it is oxidized, it gives rise to methemoglobin. That's why it is an oxidized hemoglobin. The ferrous ion gets converted into ferric ions. And these ferric ions, which is present in methemoglobin, has high affinity to cyanide ions. What it does, the ferric ions present in methemoglobin binds with cyanide, and this binding of cyanide, it forms cyanomethemoglobin. The cyanide, which is present in the cytochrome oxidase, an enzyme of mitochondrial origin, and it withdraws the cyanide ions from cytochrome oxidase. That's why it allows the to function properly about this enzyme, and thus it reduces the lethal effect of the poisoning, and hence it can have easy cellular respiration, and hence it gives its effect. It is having another mechanism where it generates the nitric oxide. It is easily converted to nitric oxide in tissues under hypoxic condition, that is very where there is less oxygen, and this nitric oxide which is formed interacts with cyanide bound cytochrome oxidase, and it displaces the cyanide ion, and the cyanide ion which is displaced allows the cytochrome oxidase to undergo normal aerobic metabolism, and this sodium nitrite has immediate effect, and this is followed by administration of sodium thiosulfate. Sodium nitrite is followed by sodium thiosulfate, and because of this it has synergistic effect. How it produces this synergistic effect? What is this synergistic effect? Will be the subject of discussion for the coming presentation. Till then, have a nice day. Thank you.